Hello, welcome to the New Stack Makers, a podcast where we talk about at-scale application development, deployment, and management. We'd like to thank Cloud Native Computing Foundation for sponsoring our podcast from CloudNativeCon KubeCon Berlin. Thanks very much for the support here. We've had a great show. Hey, it's Alex Williams of the New Stack here in Berlin at CloudNativeCon KubeCon. It's the first day, and I'm here with Brandon Philips, CTO of CoreOS, co-founder of CoreOS. Welcome.
Thank you. Thanks for having me.
We were going to talk about Kierkegaard, but I thought we decide maybe later over beers or something.
Yeah. Got to keep the viewership of the podcast high.
We actually made a pancake beer mug.
Oh, really?
For the pancake breakfast.
Wow.
You know. You guys announced that today Rock is part of the Cloud Native Computing Foundation, but I want to back up a little bit. Maybe we can use, that is kind of our anchor for the discussion. But I've been really interested in, the evolution of these communities that we're seeing unfold. The Kubernetes community has just morphed into something that no one, I think, would have expected 2 years ago.
Yeah.
It's the number one pull requests on GitHub, 30 plus commercial distributions. The growth is really quite astounding. But if you look back, the question I am always thinking about is how did we get here, right? And often I trace it back to around circa 2007. And we saw Twitter, and it basically eventually became an API, right? That really came out of, I think, like the interest that people had in connecting things. People always are trying to connect things, right? Cloud service is an example. People are always trying to connect things. I guess my question for you is how do you think back on that time, and then think about Rocket today and what it is and how it represents that evolution?
For sure. So it really spans my entire career.
Yeah.
So when I started, it was all about bare metal. I was working on SUSE Linux, and people were concerned about how do I install Linux and then get that LAMP stack up and running. And it was always very much SSH driven. I need to worry about how is my data center configured, how is all this stuff configured. Fast forward to the next leap that I made in my career, which was at Rackspace. And this was right in the time where AWS has really gotten its feet under it. Everyone is deploying to the cloud, and it's shifted really how people thought about infrastructure pretty substantially. And the main thing is that you could start to think, not completely, but a little bit more about having machines dedicated to particular tasks. The trouble there was it was always very clumsy. We had tooling that tried to make it less clumsy, but it was always the primary concern that you had at that time was what does that pipeline look like from source code to virtual machine? Right. And you had to worry about that whole stack all the way from source code to virtual machine. And every single project that I worked on against Rackspace Cloud, we had to worry about that entire pipeline on every new project, which took a couple of months just to get that pipeline going. And every time you invented new networking topologies, new load balancing topologies, it was just kind of a lot of work. And then I think transitioning...
A lot of engineering time.
A lot of engineering time when really every single one of the end results looked very similar. It was just, some new tool had come out, we had learned some problems with the tools that we built previously, et cetera, and so we wanted to move it forward. And so coming out of my experience at Rackspace, what really kicked off our thinking around CoreOS was there's got to be a better way of, instead of throwing away virtual machines, stopping worrying about that infrastructure layer and actually create a home for the application that you don't have to throw away that effort that first month or two of just, yes, we have our source code deploying into the cloud. And so that's kind of the evolution of what I've seen in the industry, and it kind of leads us up to the introduction of containerization and orchestration on top of lots of machines.
The introduction of containerization on top of machines seems like a natural evolution out of the whole platform as a service movement too, right? Where like there was like all these efforts to try to like find ways you can compose applications, but none of it was really good enough, right? It was also opinionated, and so you really couldn't innovate, really.
Right, so at Rackspace, we were building a big globally distributed monitoring system, and there's no way an off-the-shelf PaaS would fit exactly what we needed to do. We had a ton of little microservices. Some of the infrastructure ran on physical gear because we had these huge data stores, Cassandra data stores for all the time series data. And so just like, it wasn't enough. We could probably cover about 40, 50% of the infrastructure. Whereas one of the things that we kept reinventing every time was, we had to deploy the Python microservices one way because Python had its own packaging system, and then our Node.js microservices another, and then we had packaged the Java stuff into jars. And these were all the little sharp edges that we ended up every time having to reinvent a new deployment pipeline for, and like new scripts to deploy VMs that ran that Java machine versus the Node machine and so there's just all this reinvention every time we introduce even a new, something as trivial as a new language into the stack.
Right, and so that really then brought up the questions of, so then we saw containers emerge, right? And that was about the time that I think you guys were thinking a little bit differently about services too. You were thinking about, what were you guys thinking about at that time? Because you guys have known each other for years. The Solomon Hikes and and Alex and yourself, and there's a whole group of people who were kind of part of this kind of this very interesting time. What were you guys thinking at the time? And maybe that can be a segue in how it led to Rocket.
Yeah. So in 2000, I guess it was 2013. Yes, 2013. What we were trying to think about was, all right, let's assume that the market starts to get containers. What are the things that they're going to be looking for? So first is that we knew that containers were an emerging system. And we'd also been burnt a few times on previous systems about just trying to keep the things secure and up to date. So one of the first things that we knew that we wanted to do was, look, we're going to have to build new systems here, but we want to make sure that we're able to evolve those systems rapidly over time. And that led to the introduction of CoreOS's first product of Container Linux. The other thing that we were trying to figure out was, well, how are we going to get workloads into containers? We had done some prototypes. We've been playing around with some technology, and that's when Docker came out. And really the gigantic innovation that led to the explosion of containerization was, look, here's a really simple DSL that will get applications into a container and ship it around. And so with that kind of combination of technologies of how do we ensure that we are able to ship the latest and greatest as containers emerge, which was what Container Linux by CoreOS was doing, and then the emergence of how do we get workloads into containers with Docker build, we kind of saw the initial spark that's led to, Kubernetes and et cetera, all the way to today.
So Rocket got introduced into the CNCF today.
Yeah.
Why is that important?
Yeah, so the reason I think that's important is first...
Maybe you could explain, but in your explanation, help people understand what Rocket is.
Sure.
And so then that can give context.
For sure. So today's announcement, CNCF added 2 new projects. Jointly proposed Containerd and Rocket.
Right.
Now, what these projects do is they are downloading and executing a container image. So we talked about the build side with Docker build. We talked about the underlying operating system with Container Linux in the deep past. And what these container engines do is they're on the execution side. So assuming the container's already been built, assuming the container's hosted somewhere on the internet, I need to now download it onto the server that's been told to run it, and then I need to execute it and get that actual running process on top of a Linux host going. So that's what they do. And so why this is important is inside of every cloud native system is containerization. It is the bedrock, as the virtual machine was the bedrock of 2007
right.
To today. The bedrock of cloud native is execution of containers.
Right.
And so that's why it's important. These technologies are foundational. They're foundational to everything Kubernetes does. Kubernetes is focused on the infrastructure operations experience, and that means downloading and running and monitoring containers.
So doesn't the container then just become a commodity in many ways, though?
Yeah, for sure. Like that's the hope and the dream. Like, I think one of the hopes I think that everyone had of cloud was cloud portability.
Right.
Of the idea that my cloud was a commodity. I could take that virtual machine from AWS and I could move it into my own data center on my VMware cluster. But it never emerged for a number of technical reasons. And with the commoditization of containers, what it means is that people, through all the hard work people have been doing with specifications, through these multiple implementations, people can have confidence that they build their application once, put it in a container, and it will run essentially across any place that has compute, network, and storage, whether that's cloud, hybrid, bare metal, et cetera. And commoditization is a very good thing. It means that this technology will be extremely widely deployed. So.
But, okay, so there's differences in terms of cloud infrastructure, though, right? There, for instance, on Microsoft Azure, right?
Yeah.
With containers, there's the rebuilding process of a container can actually be quite complicated, right?
Yeah.
You deploy a container, but maybe there's an update to the operating system, and then the container has to be updated accordingly. Now, when you're starting to have those kind of complexities kind of like built into the process, how do you achieve that commodity? How do you, because those containers are changing, does that still allow for the code to operate independently?
Yeah, so there's a few things to unpack there. First is that the container images themselves are, in all these systems, are completely immutable. They are signed, they're cryptographically hashed, and you get a digest out of it. Now, there is the separation of concerns of the container image and the files inside that container image, and then the operating system that's executing the container image. So the operating system underneath can be updated independently of the container image itself. Now, there is this ongoing concern of, oh, I have all these container images. What happens during the next OpenSSL vulnerability? And that's where you start to build technologies on top. And technologies that honestly were kind of hard to do in the virtual machine age, where because these are immutable things, you can actually go through and audit everything that's running on your system and say, here are all the immutable versions that I have running on my system, which ones contain a vulnerability. So I think people have had this conversation about like, oh, containers are scary because I have a lot more software. But the great thing is that it means that they're actually auditable. You have a immutable asset that you can audit offline and actually figure out where am I exposed, versus in the VM age where you had these fancy monitoring agents that had to be like operating system specific and may not actually be aware of the workload. They may not find the Java jar that I copied over in order to do my deployment, et cetera. So it's actually, I think, up-leveling the discussion that we can have around those sorts of concerns.
So Rocket in particular has a security focus, doesn't it?
Yeah, for sure.
Why did you build it that big? Tell us about the philosophy behind the architecture.
Yeah, so with Rocket, what we were trying to do, we had a few specific problems that we were trying to solve with Rocket. The first was that we wanted to build something that was really easy to compose into other systems. And what that meant was that Rocket allows you to execute container images just like you execute any other normal Linux process. This has advantages in that we've seen integrations of Rocket with Mesos and Nomad, and people use it with systemd, et cetera. So it's really easy to integrate. Also, we created this kind of novel stage system, which is where we work really closely with Intel, where you can start to do interesting security things like wrap the entire container, the executing container, in a virtual machine pretty much transparently to the user.
Clear container?
With Intel Clear Container. And so you can start to do these differentiated, interesting things with the way that we built Rocket, where you can say, actually, I don't trust this container image, I'll wrap it in a VM. Or there's a bunch of other things that we've been doing around how you might audit that VM, et cetera. So it was really two things that we're going for, composability and then a bunch of the security primitives.
So what's next for Rocket then? So it's now part of CNCF. So what does that do for Rocket and how it evolves?
Yeah, so there's a few things that we hope to see with Rocket. First is that Rocket currently is passing 84 out of 89 conformance tests for Kubernetes. So we'd love to, through increased collaboration through the CNCF, get Rocket to passing 100% of those conformance tests. We have a lot of people using...
The performance is like working at...
Conformance.
What?
Conformance.
Conformance.
Yes.
What's conformance?
So the conformance tests essentially are a subset of the Kubernetes testing suite to say this is actually a working cluster. So,
I see.
Yeah.
Is there? I know that when you're testing for kind of performance with Containerd and Rocket.
Yeah.
Are we seeing 100%? Are we able to? I understand that there may be some things just they're still trying to work through. There's some gap in terms of how they work together, in terms of testing and continuous integration.
Yeah. So the places that Rocket and Containerd share is through specifications. So through the Open Container Initiative, essentially people can have confidence that the exact same containers they ran under Containerd will run exactly the same under Rocket. The main differences come down to architectural differences and how people actually want to maintain the process tree, et cetera, et cetera.
Right.
So that's kind of where these two projects will continue to work together. So
that's kind of that's part of what's next then.
Yeah, for sure.
Right.
What's next? I'd love to see OCI hit 1.0. That's a project that I've been sitting on the board and trying to help shepherd through for 20 months now.
Yeah.
And so it's really critical. We saw Amazon release OCI support with their container registry. We'll be doing the same with Quay, and I hope that we'll see OCI kind of become the de facto packaging specification across all this cloud native technology.
I was told it's about 2 months away.
Yeah.
But that's what I was told 2 months ago.
I know. It's tricky getting these things out the door.
Is it due to the open compliance? I mean the open nature of the organizations?
Yeah, I think so for some history, our intention initially with OCI was to get it out the door in about 8 months.
Yeah.
And so we're about a year late. And the spec is in really good shape, honestly. Amazon has implemented the spec completely independently.
Yeah.
Barely talked to any of the engineers. Seemed to get it right. We have independent implementations through Containerd, through runc, through Rocket, et cetera, et cetera. And right now, it's just ensuring that all the language and everything looks good so that when we hit 1.0, we can have a lot of implementations that are compliant. So it's in RC5 or something, 1.0 RC5, and it's overcautious engineers, honestly.
Well, you gotta make it real sometime, right?
Exactly.
Well, thanks so much for joining me, Brandon. I really appreciate it.
Yeah.
Thanks for taking the time. Good to be here in Berlin. I know you guys have roots here now, so look forward to the conference and keeping in touch.
Yeah. Thanks so much for having me. Yeah.
We'd like to thank Cloud Native Computing Foundation for sponsoring our podcast from CloudNativeCon KubeCon Berlin.